Mole concept. So, we use Avogadro's number in chemistry. Avogadro's number is the number corresponding to a mole, and we'll talk about a mole in a second. It is the number of carbon-12 atoms in exactly 12 grams of carbon-12 isotope of carbon, which is approximately 6.022 times 10 to the 23rd atoms. So, this Avogadro's number is going to be very important for us to understand how we can calculate the number of atoms a certain sample of an element has. Now for a mole. You might be wondering, what is a mole and what does it have to do with chemistry? That's what I wondered the first time I heard mole. 1 mole of a substance contains Avogadro's number of molecules or atoms, so 6.022 times 10 times 10 to the 23rd atom. So if I write 1 mole, this is the abbreviation for mole, equals 6.022 times 10 to the 23rd atoms, or molecules if we're talking about molecules. So the mass of 1 mole of a substance in grams is the same as the mass of 1 molecule or atom in atomic mass units, or AMUs. Usually you find these atomic mass units using the mass number of the elements, the element for the atom you're talking about, or the elements when you're talking about a molecule. When you will add them up to figure out the atomic mass of a mole of a substance. Why do we use moles? Moles are important because they allow us to compare substances. So when I have, let's say, 1 mole of H2O, 1 mole of water, what we can see here is that 1 mole of water equals about 16, it's going to be the mass, the atomic mass units of H2, so 2 atoms of H and 1 atom of H2O. So 2 atoms of H equal 2.02, they equal 2.02 grams per mole. And then we can see that oxygen equals about 16.00 grams per mole. And when we add them up, we're going to get 18.02 grams per mole. What this tells me is that for every 18.02 grams of water that I have, if it's pure water, I'm going to have 1 mole of H2O. Now this helps us to compare this to, let's say, if we have 1 mole of oxygen. 1 mole of oxygen is only going to be 16.00 grams per mole. So that means, and I get that number from the mass number of the from the periodic table. So that's 16.00 grams per mole, and that tells me that every time I have 16.00 grams of an oxygen atom, I have 1 mole of that oxygen atom. This also tells me that if I have 18.02 grams, I have 1 mole of H2O, and I also have 6.00022 times 10 to the 23rd molecules of H2O. And if I have 16 grams per mole of oxygen, I have 6.00022 times 10 to the 23rd atoms of oxygen. Notice now we can compare this 1 mole of H2O to this 1 mole of oxygen, even though we can see that their masses, their atomic AMU mass units, are different because of what they're made up of. So an easy way to describe this is if you have a dozen. A dozen usually means 12 of something. Let's say 12 eggs. So let's say you have a dozen, it's going to equal 12 eggs. But let's say you have very big eggs, and then very small eggs. If you have 12 of these big eggs and 12 of these small eggs, which one will probably weigh more, will have more stuff in it? The big egg. But we would still call 12 of these big eggs a dozen, and 12 of these small eggs a dozen. So let's imagine that this is the mole, and then these are the grams, or the weight of this egg and this egg are the molar masses that you're finding here. So a mole helps us understand the relationship between the atoms or molecules of different atoms, of different elements, and helps us relate that the mass of 1 mole of a substance in grams is the same as the mass of one molecule, like we have here, or atom, like we have here, in atomic mass units.